Hello everybody, good to see you again. I hope you're enjoying our information technology series on the practical assessment task, or PAT, as much as I am. Let's see how far we are. So far we've looked at phase 1 and phase 2, in which we've covered program specifications, algorithms, IPO tables and classes, objects and data flow. The last phase, phase 3, is about implementation and creation of the program. Today we're going to start to design a database for your practical assessment tasks. Tabo is joining us as usual. While we wait, let's look at what we're going to cover today. At the end of this lesson, you should be able to identify data that must be stored permanently, determine the data that must be stored in text files, and indicate how data structures will be shown in each text file. This must be Tabo. Good morning.
Morning. Please tell me we can start programming already.
What's my motto, Tabo?
If you fail to plan, you plan to fail. I get that, but what else is there to plan?
The patch you're working on is going to test the user with multiple choice and match the columns, game type tests, right?
Yes.
There will probably be 100 or more terms and corresponding definitions to store, as well as details about the users, like their usernames and passwords.
Yeah?
Do you know exactly, and I mean exactly, what the data is that you have to store permanently?
No.
If you don't even know what data has to be stored, how can you be sure where or how to store it?
Good point.
That's why it's important to design your database and text files before you start creating them. When designing permanent data storage structures for a custom software solution, you should ask yourself, which data must be permanently stored? Which of that data should be stored in a database? And which of that data should be stored in text files? What is the easiest way to determine what data needs to be stored? Come on, think back to the work you've already done on your PAT.
The IPO tables. You told me I should save information about what we need for the database in a separate document.
That's right. When you created your PAT's IPO tables, you made notes in a separate document of what must be stored, as well as the data type for fields in the database. We identified that our database would have to include information on learners, which is the name of the table, containing grade, first name, surname, username, and password. They will all be of the data type string. We'd also have to store terms of which term is a string, correct answer ID, which is an integer. This will allow us to get the correct definition from the definitions table, and of course definitions, also a string.
We saved this information under files needed.
Yes, Tabo. What else can we use to determine what data must be stored?
The class diagrams and data flow diagrams.
Very good. Let's look at an example of a class diagram. What does this class diagram tell us?
The question and the number of the correct answer must be passed as parameters. That means they have to be stored somewhere so they can be sent to the object when it's created.
Yes. Let's add the flow diagram. See where you indicated data store. You are referring to a text file, database, or object where the data would be stored.
And we've already shown the private fields that will store data in the objects.
Exactly. Look at your IPO tables, as well as your class diagrams and data flow diagrams. Identify all the data that must be permanently stored. Make statements about the file type they need to be stored in, and state what must be stored, as well as the data type for each field in the database table. We've established that we can store data in either database or text file. Which data would you use database storage for in your pet?
Input you get from the user, like his name, surname, username, and password. Also terms and definitions that we need for the games.
Okay, let's assume that this is the data you have decided must be stored in the database. Write down each separate data item as a field. Write the field names you will use, which should describe the field's contents, and remember to show the data types. If you know that certain items must be stored together in one table, give a table name like learners, terms, or definitions. If you're not sure which table to put some fields in, make a heading Other Fields and write them there. Don't worry if you're not sure about anything we've shown so far. We'll get to that. Just get it written down. That's for database storage. Your other option is text files. What types of data should be stored in a text file? Think of your pet. What data could you safely put in a text file?
Stuff that isn't personal and stuff that doesn't need to be protected.
That's right. There is no way to protect the data in a text file, apart from the file's property settings like hidden or read-only. So you can't store sensitive data like personal data in a text file. Also remember that data from a text file must be accessed in sequence, line by line.
Of course, you can't randomly access a separate line or word of the file.
Yes. If one thing in one line of text must be inserted, edited, or deleted, the entire file must be transferred, line by line. You'd have to transfer it to some other storage object, like an array in RAM, then make the necessary changes there. Then write the array's contents to a new file, or to the same file on the hard drive, line by line.
That's way too complicated. I'd say avoid using a text file for data that has to be accessed randomly.
I agree. What about checking the data in a text file to see if it's in the right format, running a spelling check, or putting data in the file into groups that are related in some way? Like in this example. Can you check format or spelling?
It's all text, so there's no point in checking the format. And you'd have to add something to each line so you can see which group it's in. You still need to look at the file or write a program to sort out the groups.
So there's no way of validating data, avoiding errors in input, identifying specific data items, or creating relationships between data items when using a text editor.
Code would have to be written for every use of the file.
True. It's a good way to transfer data between programs, but it's a very simple storage medium. It may not provide enough features to store data that needs frequent or complicated processing, or that needs to be protected or checked in any way. It's important to keep this in mind when you decide how to store the data for your pet. If you look at the IPO tables and class diagrams from earlier lessons, you'll see you've already identified a need for the following text files: admin password.txt, firstname-surname.txt. Let's take a closer look at them. First, let's look at admin password.txt file. We need one file to store the encrypted admin password. It will be an unstructured file because there will be a single word in this file. We also identified the firstname-surname.txt file, a file for each player that will store a game history showing the date, the level or grade, score, and the terms the player got wrong. Every time the player completes a game, a new line will be added to his file. To separate the different data items in each file, a delimiter is used. We indicate it with the use of a hash sign. You could also use any symbol that will not appear as a character in the data. Let's look at an example. In this file for the player John Mueba, each line represents the record of a game he played, with fields separated by hash signs. We have to put the data into groups this way, because this text editor can't group data. We can't use the / as a delimiter because it appears as part of our data. Notice that we put date, level, and score first on each line. After those 3 fields, there are between 1 and 3 fields on different lines. When you have to extract the fields from a string, put irregular amounts of data at the end of the line. You can also use a different delimiter instead of the hash to show where the irregular fields start.
Looks like John played more than 10 years ago, and the program hasn't even been written.
That is another example of what can't be done with a text editing program. We will have to validate the data from our program before we save it in the file. For phase 2 of the PAT, when you explain your file structures, it's only necessary to state what the contents will be. No diagrams are needed, but it takes very little time to create an example like the one we've just looked at. And it can help in the explanation of the design. If you don't use a diagram, you can describe the text files like this: admin password.txt, the name of the file, and encrypted password, the contents for an unstructured file. First name surname.txt, the name of the file, and game history for each user, a description of the contents. You could also use date hash, level hash, score hash, terms wrong, the fields in the record. When you design the files for your PAT, think of some added value you could give your client.
Added value, meaning?
Functions that the client didn't ask for, but that could make a better program.
Can you give me an example?
Well, you say your program should teach IT terms and definitions. The teacher might find it useful to be able to analyze some of the data after a while to see how the learners are coping. What numeric data do you think she would be interested in?
Gosh, there are lots. Average score, highest and lowest score for all the learners. Seeing how many times the learners give the wrong definition so she knows which terms are giving the most problems. And she might want to draw a graph, but that will be very difficult to do in a program.
That's where spreadsheet software is useful. She will be able to do any kind of calculation and create graphs or charts without you having to include coding in your program. Just add some code to transfer the data she needs to a file that can be used by a spreadsheet program. In what kind of a file would you store the data to make it easier to transfer?
A delimited text file makes sense, I think. There's no point in writing a program to do the things a spreadsheet program can already do.
Let's see what you must do to provide this added value. Here's an example. A text file to show which terms were answered incorrectly most often in a program. The IT teacher could use this information to see which terms are giving the learners problems. Then she could reteach the terms. Each line consists of a term. The number of times the term had been tested in all games ever played, and the number of times the wrong definition was given. It's time-consuming to write code to manipulate numerical data in a program and give informative output. Making the data available for use by spreadsheet software can be part of the solution to the problem you are trying to solve in your PAT. If you use a text file, you can easily transfer the data to a spreadsheet, like Excel, that has many easy-to-use tools. The teacher can then calculate, say, the percentage of times users got something right or wrong. No code needed. Let's look at that example again. The terms, cluster, register, and GPU or graphic processing unit will already be stored in the terms table in the database. But the two numbers will also have to be stored permanently and incremented as the program is used. If we add two fields, times asked and times wrong, of the data type integer to the terms table and set the values to 0, we can increase them when a game has been played, if applicable. Then we just place a button named Export Wrong Answer Totals to File on the administrator screen and write code to read the fields from each record in the terms table. we create a line of text, converting the integers and adding delimiters, and write the line into the text file. So, for analyzing the learner's results in Tabo's PAT, it's best to store the data in two places: a database to record the data, and a text file for exporting data to another program for processing.
Do I have to use a program like Excel? Can't I build what I need into my program?
It might be better to use coding within the program if the required manipulation is not too complicated, and if the teacher can tell you exactly what she wants to be able to do. You could use an object available in the programming language. Take this for example. Here the data could simply be read in from the database. The IT teacher could see it from within the program instead of opening Excel, but remember, you will have to write code to work out something like the percentage of incorrect answers. Let's take a look at the player's text file again. The name of the file is the player's first name and surname. The program will have to find the correct file for each player. What is a good way to get the name of the text file? Would you ask the user to type in the file name after each game?
No. No one wants to do that. And it increases his chances of making a mistake.
What if you used the file open dialog and allowed the player to select the correct file?
No way. Then a player could select someone else's file if he gets a bad score, and add the bad score record to that file.
And if you read the first name and surname from the database table and construct a string for the file name after each game?
That's kind of pointless repetition. The file name should only be created once.
So what is a good way to get the name of the text file for each player?
I could store the file name as another field in the player's record in the database. On the other hand, I could just use the username that I'm going to transfer to the player object when the player logs on. Because the usernames are unique, so I won't have two files with the same name, and it will be just sitting there in RAM waiting to be used as a file name.
Now you're getting the hang of it. It's time for today's task. Use this text file about a game to answer these questions. Each line is the record of a game played by a player. The fields are the date on which the game was played, the level at which it was played, the score, and the terms that the player got wrong. At the end of each game, the program will find the correct text file for that player and add it as their latest data, as a new record. The program will have to find the correct file for each player. Say whether each of the following cases would be a good way to get the name of the text file and give a reason for each answer. 1. Ask the player to type in the file name after each game. 2. Use a file open dialog and allow the player to select the correct file. 3. Read the first name and surname from the database table and construct a string for the file name after each game. 4. Store the file name as a string in the player's record in the database. 5. Store the file name in the player's record and transfer it to a player object when the player logs on. This data could be manipulated if it is first read into an array. Give an example of what use you might have for part of each line, for example, the grade and score, or the terms which were answered incorrectly.